Hi everyone, I'm Veronica Ray. I'm a senior software engineer at LinkedIn, and I live in New York City and work on the video team. For video, we have to ask for a camera, photo library, and microphone permissions. As a result, we have a very complex permissions flow. Since it's a key part of the user experience, it also is well tested. If the camera permissions aren't enabled, then users won't be able to take photos. If the photo library isn't enabled, then you won't be able to upload photos or videos from your camera roll or save photos that you take in the app. And if microphone permissions aren't enabled, then you can't record videos. That sounds like a lot. It's too much to keep in your head at once. The clearest way to express this flow is with a diagram showing what it's like for someone to go through the app. This is a beautiful markup that our designer gave us for us to implement in the app. While there's actually just one entry point, there are many paths to take from there that all need to be handled if you want to avoid a broken experience. First, I'll talk about how we implemented this complex flow, and then I'll get into how we tested it. I'm going to assume here that you already implemented permissions in your app, and as a result, you already have a permissions flow. That's okay, that's where we started. While we were working towards launching video sharing for the LinkedIn app, we just added permissions code when we needed it in order to ship a feature. As a result, there was no overall approach or grand plan behind it, and it had no automated tests. This worked well. While the bugs in permissions code seriously impact the user experience, permissions code is exercised whenever you use a feature, right? When we recorded the thousands test video of our keyboards, we were also testing that we were prompted for the correct permissions, and when granted, we could record a video. Except we weren't manually testing all the cases, just the happy path. For example, whenever we got a request for permissions, we just accepted it. And once granted, we forgot about them. We forgot what it was like to be someone who had just installed a new app and had no idea what they were getting themselves into. Here's one interesting bug that we had in our first version of the permissions flow. If the member hadn't enabled microphone permissions yet, the camera roll videos had no sound. The video had no sound in the review screen, which allows you to play back the video before you upload it. It wouldn't have sound if you upload the video and then it was played in the feed. But the sound actually did get uploaded. It just didn't play for you if you didn't have microphone access enabled. Everyone else could hear it just fine. The microphone permission alert used to only come up when you opened the video recording screen, which allows you to take a picture or record a video. So you could have easily gotten into the photo picker and uploaded something from your camera roll without ever trying to record a video and getting prompted for microphone permissions. However, since we had all given access to microphone permissions a long time ago and had forgotten about it, it was hard for us to come across this bug. Fortunately, one of our developers found this bug while she was testing out the app herself, but here's how I imagine it would have gone if one of our users had come across the bug and reported it to us. Help! I uploaded a video from my camera roll, and when I play it back in the app, it has no sound. Bug report 456612. Let's see. Back in the video on-call Slack channel, I'm V-Ray. A member is saying they can't hear sound for a video they uploaded from their camera roll. Have you checked out the HLS stream? Yeah, the video has sound. I know this sounds obvious, but did you ask them if volume is turned up on their phones? They said it was. We really need to focus on fixing issue right now, so I'm just going to close this as cannot reproduce. Hey, it's Video iOS on call here. I haven't been able to reproduce this issue. Let us know if you run into it again. Jira status closed. When a bug can't be reproduced, it usually means there's something wrong deeper under the surface. Either something is wrong that's highly specific to the user, microphone permissions aren't enabled, or there's a larger problem that isn't well understood yet. For example, a user couldn't upload videos. Turns out they were blacklisted. This prompted us to look more deeply into our logic for whitelisting and blacklisting members. Another example is that one part of the code had so many cannot reproduce bugs, it prompted us to add more testing and logging, and then eventually refactor it. The second problem with our permissions code is that it was all over the place. We tend to have our permissions code right in the code base where we're asking for permissions. We previously had a photo access helper that consolidated code for asking for camera and photo library access, but it didn't include microphone access. After lots of time searching and talking to folks, I was unable to find where or how we asked for microphone permissions before we implemented our new approach. This troubles me. It's a huge problem with your architecture if a developer who knows the way around the code base can't find where something is implemented. I did a lot of digging, searching through the code base myself, and talking to people. I couldn't find any video-related code that asked for microphone permissions, but there was another feature of the app that was using microphone permissions as well. I was aware of this feature because for each permission in the permissions alert dialog, you can only give one reason. So I had been working with my product manager to figure out a reason that could fit both features. I sent a message to the developer of that feature, and here's how the conversation went. Hey, I'm working on permission flows for video sharing and interested in learning how we currently request permissions in Voyager. That's the name of our main iOS app. I saw in your original response, we deleted that part of the code to request permissions, but basically that line of code will. So this mystery continued to be unsolved, and it still haunts me. One day, I'll get to the bottom of it. So the solution to the code all over the place problem is to create one permissions helper for all your permissions. For us, it's camera, photo library, and microphone permissions, but there could be other permissions in the future. There will be no more redundant code or detective work needed to track code down. We have a singleton permissions helper. You initialize it with the classes that are used to determine each individual permission. For example, for microphone permissions, it's AV audio session. This approach allows us to do dependency injection so we can mock out all the different authorization states for testing. Next, we have one enum for the permission type. This allows us to not have separate functions for displaying our app-specific alert messages. These app-specific alerts are all UI alert controllers. We just need to know what text to set. However, we still need separate functions to show the system alerts. The logic is slightly different for each permission type. This is the code to show the system alert for microphone permissions. And if denied, show our fake alert. You can see how it makes use of AV audio session record permissions. So what are these real alerts and what are these fake alerts? Because the system alert only appears once per install, we have a fake alert that we can show after a member denies the system alert to give them a chance to change their mind. There's a balance here because repeatedly asking for a permission after it's been denied is annoying. But we're also only asking for the permission when the user is trying to get a feature that requires it. Since it could become annoying to see a permissions alert over and over again when you enter the photo picker, we made a design decision that lessened the annoyance. Instead of repeatedly showing an alert to someone without camera roll access, we have this button on the photo picker. If someone is wondering why their photo picker is empty, they'll see exactly what the problem is and how they can solve it. You only get one shot to ask the system alert per install. This sounds tough, but it's really not a difficult limitation. You just create a fake alert that takes the user to settings so they can change their permissions. Some UI quirks are that you won't be able to deep link into app settings using your fake alert if you haven't asked the system alert first. You'll go to the regular phone settings instead and will probably very much confuse your user. If you don't ask the system alert first, you'll see this user experience. The member is taken to the general phone settings and needs to then navigate to LinkedIn settings. As you can see, it takes you to wherever you left off in the settings. In my case, it was the Bluetooth page, so I could connect my snazzy AirPods. To avoid this issue, please ask the system alert before you show your fake alert. These different experiences all come from the same code, and it's because of the different behavior of UI, application, open settings, URL string. Until you've asked the relevant framework the status of the authorization, which shows the system alert, that permission is not part of the app's custom settings. Unfortunately, this also can lead to confusion if somebody downloads the app and knows what permissions they want to set, because when they go to the app's specific settings, they won't actually see the permissions. They will only see it after you ask the system alert in the app. Our implementation didn't look like our designer's beautiful mock-up for many reasons, especially due to constraints imposed by Apple's APIs. So first constraint I talked about was the fake alerts versus real alerts. Unfortunately, once you show the system alert, you have to show your fake alert, which takes the person to settings instead of automatically granting permissions. Also, when you change the permissions in the device settings, the app closes. When you open it again, you'll be back at the initial state of the app. For us, that's the feed. So if you're prompted for photo library permissions in the photo picker, and you get deep linked into the device settings for LinkedIn, and then enable photo library permissions, when you go back to the app, you're going to be on the feed and will need to make your way back to the photo picker again. This is not the optimal experience, but there's no way around it. Since the app closes when you change these settings, you'll see this as a crash in Xcode if you're developing on your simulator. Don't be alarmed. Test on device to see what the actual behavior will be. We implemented this great centralized approach to permissions for just video, but the onboarding and profile editing parts of the app also ask for camera and photo library permissions. Because the LinkedIn main app is so large, these parts are managed by completely different teams. I've been part of these multi-team refactorings in the past, and I actually like to do them as much as I can, but given the timeline for our video sharing launch, this work was not feasible. Here are some design best practices for how to implement permissions in your app. First, ask for permissions only when you need them. Don't bombard the member with a bunch of permissions dialogues when they first open the app. For us, the only permission we ask when you first open the app is to allow notifications. At this point, people don't have sufficient context about the permissions you're asking for and are more likely to deny them. Wait until someone wants to share a photo before asking for photo library permissions. Second, if permissions are necessary for an experience, don't let the user proceed without them. We don't let someone take a picture in the app without giving camera permissions. If your app is, say, a self-tracking app that makes use of health data, your app might just be empty without health kit permissions. Just showing that empty state should be enough to let the user know that they really should accept these permissions. Finally, if permissions aren't necessary, let the user proceed without them. If someone hasn't enabled photo library access, they can still take pictures and record videos in the app. We don't keep showing the permissions dialog to them if they don't need to grant permissions in order to proceed. The second solution we have is automated testing. It was a major challenge to test every possible scenario in the flow, and given the trade-offs involved, you might end up making a different decision and not have as thorough automated testing for your permissions flows. We have very high code coverage goals for automated testing at LinkedIn, and a lot of tooling available to make it easier. But if you have QA, or if you also have a manual playbook, those might also be great solutions to verify your permissions flow. I'm going to go in how we did automated testing. At LinkedIn, we have an approach to testing called the test pyramid. The vast majority of your tests should be unit or layout tests, and the rest should be scenario tests or UI tests. This reduces the time it takes to run the test suite in our continuous integration system and reduces issues caused by flakiness in scenario tests. Let's go back to the permissions helper. I said that we designed it in such a way so that we could do dependency injection. We can mock out the current permissions in order to test all the possible scenarios. We have 13 unit tests that exercise that the right alerts are displayed and that the completion blocks are called. This was the extent to what we could unit test for the permissions flow. This is what the photo library wrapper we created looks like. It's very simple. Unit tests are great, but we're missing a key element. Remember this complex flow? We need to also verify that we're following this correct flow throughout the app. We want to ensure that there's no point in the app where the member lacks permissions and is also not prompted for them. This could create a broken experience. For example, they might not see photos or videos in the photo picker and will not know why. You might have noticed that these flows cannot be run on a simulator because they involve recording videos. According to the testing and debugging and simulator documentation, this is the list of limitations in the simulator as of iOS 8.2, but there also haven't been any changes since then. If you want automated scenario testing for any of these features in your app, you'll need to run tests on real devices. This is currently not fully set up and running yet at LinkedIn, so I will not go into detail on our approach, but as you can imagine, there are huge trade-offs involved for running your automated tests on real devices. We primarily use the Facebook framework KIF for our scenario testing. There's an acknowledge system alert function. What it does is dismiss the system alert with the last button. Usually that's allow. But we also want to dismiss the dialog without allowing access, because that's a distinct action that someone can take in our flow. So we can't use KIF for our test. That's fine. There are other scenario testing frameworks we can use. Let's explore our options. Earl Grey is Google's more recent framework for scenario testing. It was released in 2016 and is actively maintained. Unfortunately, it doesn't fit our needs here. XCUI test is Apple's framework for scenario testing, and it does work for us. We are very excited now because we have a framework that supports the kinds of tests that we need to write. This is what one of the complete tests looks like. I'm going to point out important aspects of these tests that warrant further explanation. First, we have this make UI interruption monitor function. The goal of this is to stop system alerts in their tracks. We need to be able to stop a system alert and then take the action that we want to take on it. This is the code that we wrote behind the scenes to centralize the process of adding interruption monitors. Add UI interruption monitor is an XCUI test instance method. Using our helper, you can input the type of permission and whether or not access is granted by the member, and then we'll add the correct interruption monitor. When you're done, you need to reset the permissions. Between tests, you can delete the app via the Springboard in the teardown phase. Springboard is the standard application that manages the iOS home screen. It's like the mobile version of a desktop. One important thing to note about this code is that it makes use of a private XCTest header. And there's a lot of code here, but it basically just gives you an idea of what you'll need to do. And this is code that is, published on GitHub by someone who found out how to do it. And I will give more information soon about how you can figure out what different strings to use when you're doing these kinds of tests. So some tricky bits is that for the alert handler to fire, you must interact with the app after creating the UI interruption monitor. For example, tap on a button. Then make sure to remove the handler once you're done. Otherwise, the same handler will be invoked for any other alerts that appear. Second, we seem to have a lot of strings here to identify elements. Where do all these strings come from? Most elements will have accessibility identifiers if you have made your app accessible. For those that don't, we have ways of identifying them. As I said earlier, we have both fake alerts and real alerts. These two alerts are implemented differently, and they require different approaches for testing. For system alerts, we can use the UI interruption monitor. The fake alerts are UI alert controllers. Since they're UI alert controllers, they do not have customizable accessibility identifiers that we could use for tapping. But every UI element does have an identifier. We just need to find it. You can fill out the body of a test method just by going through the flow in the app if you use UI recording in Xcode. Instead of normally what you would do, which is thinking of a test scenario and then sitting down and writing the code to simulate it, the code is generated for you. We use UI recording to identify elements that didn't have customizable accessibility identifiers, because if you don't use UI recording, you're basically just guessing. You might have noticed that during the flow, we are leaving the app and then coming back. How do our scenario tests handle that case? Some potential solutions we thought of are to mock the action button to not actually take the user to settings, but to just act as if the status has been changed. You could also perform the actions, kill the app, and then relaunch it with the new settings. But changing the settings kills and relaunches the app already, and it's functionally equivalent to running a different scenario test that tests a different permission status. So what we ended up doing is verifying that the fake alert appears and then always tapping cancel. Our work here is done. As you can see, there were significant trade-offs when it came to writing automated tests for permissions flows. While I'm very confident in the code we have for permissions, it comes in part from having a centralized helper and having the code be well organized, and also have that great diagram and planning out what all the different cases are, and then also having testing. For us, it's automated tests, but you could also have a up-to-date manual testing playbook or another way of going through these flows regularly. But as I said, don't just trust that by using the app you're going to hit all these cases, because you'll basically have granted these permissions already and you'll just be hitting the happy path. The great changes for location permissions got most of the attention at WWDC this year, but there were also some interesting changes to photo permissions. For example, apps using the native picker no longer have to request access to the member's entire library to import just one photo or video. User selection of a photo or video is an implied permission. no alert is shown. Next, write permissions now have their own alert. I think these are both subtle but great changes for improving user privacy and only asking for what you really need from someone. And I think it's very much similar in spirit to the changes made to location permissions. To recap, poorly tested and unorganized permissions code leads to unsolved mysteries. Thank you for sharing this journey with me, and may all your bugs be reproducible.
Thank you, Veronica, for sharing with us a more elegant way of testing or requesting for permissions in our app. So does anybody have any questions for Veronica? Okay, none at the moment. So you can ask her any questions you have at the break. Thank you again, Veronica, for giving us that great talk.